Page 60, continuing lesson 19 on scientific notation. Key concept here just kind of mentions again about scientific notation. If we have really big numbers or really small numbers, we can use that as a condensed way of writing the numbers. Also, it makes it easier to compare numbers by looking at their exponents. And again, for scientific notation, we want just one number and then a decimal point times 10 to some power. If we have a big number, it's going to be a positive exponent. If we have a small number, if the red decimal point wasn't there, look where it is originally over here. A small number less than 1 is going to have a negative exponent. So if we look at this, do you understand what is scientific notation and why is it used? We already kind of mentioned that. Again, it's a way of writing numbers in a condensed format, and it's used to so we don't have to write as many zeros, and so we can more easily compare numbers to each other. Number 2, Taylor states 2,800,000 in scientific notation is 2.8 times 10 to the negative 6 because the number has 6 places to the right of the 2. Is Taylor's reasoning correct? So we could say that it should be actually 2.8 times 10 to the 6, not negative 6. Big number is going to have a positive exponent on it. Number 3, Sam will write this number in scientific notation. Sam thinks the exponent of 10 will be positive. Do you agree? And this one would be no. It should be a negative exponent. Again, and any number less than 1, if you have a decimal less than 1 like this, it's going to be a negative exponent, because if you have a negative exponent like this would be negative 5th. So we could put 3.2 times 10 to the negative 5th power. Remember, 10 to the negative 5th is like 1 over 10 to the 5th, which means we're dividing by 10 5 times. When we divide by 10, moves our decimal to the right. When we multiply by 10, when we divide by 10, moves the decimal to the left. When we multiply by 10, moves the decimal to the right. Number 4, they want us to write that in scientific notation. So first thing is we need to figure out where our decimal point needs to go. So we want one number that's not 0 and then the decimal. So a 5 is not 0. So we can put a decimal right after the 5. The decimal starts out at the end after that last digit. So then we just have to look how many spots we moved the decimal. So we moved it 1, 2, 3, 4, 5, 6, 7 places. Nope, I didn't count right. 1, 2, 3, 4, 5, 6, 7, 8 places. Okay. And then what we do is we write all the numbers that are not zeros. If there's just zeros at the end, we don't need those. 5.864, remember, just like with decimals, if you add zeros on the end, doesn't change the decimal. And this would be times 10 to the 8th power. We moved 8 places. It's a big number, so we need to multiply by a bunch of 10s to get it back to where it was. So this is scientific notation. Again, the number, how they wrote it originally, is called standard form. If they ever ask you about standard form, again, it's just how we normally write numbers. Number 5, genetic information of almost every living thing is stored in a tiny strand called DNA. Human DNA is 3 nanometers, or 3 times 10 to the negative 9th meters long. Write the length in standard form. Oh, there it is. Okay, so there's our decimal right now. Times 10 to the negative 9th. We need to figure out how many places we're going to move our decimal and what direction. So this, we would actually want to move the decimal 9 places to the left. So one spot gets us in front of the 3, and then we need 8 more zeros. So that's what that would look like, only you don't have to write it as crooked as that. And then we've got a discrepancy here. Apparently some books have that and some have something different. So some of the books here, it says 3.4 times 10 to the negative 8th. So if you have this, negative 8th means we would move the decimal 8 places to the left. So one spot gets us past the 3, and then we need 7 more zeros there before we put our decimal point. Number 6, the largest virus known to man is the megavirus, which measures this small part of a meter across, which we would never put in meters, I'm sure. Express this number in scientific notation. So for this, to get it in scientific notation, we're moving to the right, moving to the right. We need a number that's not 0. So we have to get past that first 4. So that'd be 4.4. And then it's always times 10 to a power. The question is, what is that power? So if you count that out, sometimes it's hard to keep track. So what you might want to do is physically say 1, 2, 3, 4, 5, 6, 7. And since this is a small number, we're going to have a negative exponent because we would have to divide by 10 to get back into standard form. So 4.4 times 10 to the negative 7th power. And number 7, how would you write the number displayed on the calculator screen in standard form? First of all, let's talk about how you would write it in scientific notation. So in scientific notation, the calculator's meaning this would be 7.6 times 10 to the 12th power. When you see the E, that's like times 10 to whatever power's after it. That's scientific notation. We want standard form. So positive 12 here, we're going to move our decimal 12 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or you can just think I'm going to move past the 6. That's one spot, and then I need 11 more zeros after that, however you want to do that. And then we'll have several commas in here. And that would be our answer. Workbook page 18, we're just going to look at a couple more problems here. So number 14, which of the following numbers is written in scientific notation? Select all that apply. So just to make this easier to keep track of, I'm going to put numbers next to these so we can keep track of what it is that we're talking about. So the first option is not bad, other than they've got 2 numbers before the decimal point. We only want 1 number and then the decimal, so that is not in scientific notation. The second one is okay. They didn't need the 0 at the end there, but other than that, it's okay. The third one has 2 numbers before the decimal, so that doesn't work. The fourth one is good. Fifth one is good. Sixth one, again, has 2 numbers before the decimal point. So,
it's not supposed to.
and then also, this isn't a big deal. You could have a 0 after decimal. Normally, we're not going to write it because it's not needed. But sometimes, even for scientific notation, even if there's nothing there, actually they do put 0.0 sometimes. I'm not sure the reasoning on that, but okay. So look at number 15. After evaluating an expression, your calculator display shows the result 4.5e negative 11. Part A, express this number in scientific notation. So scientific notation would be 4.5 times 10 to the negative 11th power. And then if we're going to write that in standard form, then we'll take that and move 11 places. Which way? To the left. Good. And then what should happen is we've got 1 spot we have to move to get to the left of the 4, and then we need 10 more zeros. and then our decimal point. And again, if you want to put a 0 before the decimal point there, you can. And just to make sure, if you guys want to double check yourselves here, if you want to group these in threes or something, to make it easier to keep track if you have the same number of zeros, because it's hard to look at. In fact, when you write your answers on these problems, you may want to, write that and then say I've got, in this case we had 10 zeros. You may want to just write 10 zeros so that when we go to grade it, you can say, oh yeah, 10 zeros. So this gives you an idea of how to work with scientific notation.